Hello everyone, welcome in this video tutorial series of how to program 32-bit microcontrollers using MPLAB Harmony version 3 by Microchip. So for the purpose of this tutorial videos, I will be using my PIC32CM that comes with the Curiosity Nano board. Let's go to our schematics first. Just drop it down. Okay, so we've got our PIC with all the power supply. Now it's very simple. We've got 3 LEDs that will be driving through the current limiting resistors from the ports, from the pins PA04, 5 and 6. We will be sourcing some current from those pins into the ground. Now in this tutorial we will be setting the state of the pin either high or low. We're not going to be toggling it yet, it's just we're going to have a look how to address the pins. Okay, so let's go to our MPLAB. Now let's start a new project. I'm going to start 32-bit MPLAB Harmony project. Okay, the path is correct. Okay, so the location of the project. Now I'm going to keep it there for a moment. So I'm going to create a new folder that's going to be called PIC pin. Okay, and the name of the project is going to be PIC pin set. It's just whatever name you feel comfortable. I'm going to click next. Okay, in here we're going to select our PIC 32, there we go, and click finish. The framework for Harmony is going to load. Okay, I'm going to click launch. Let's wait a second. Once there we go. Once the MPLAB Harmony 3 is loaded, we are welcomed by this screen. And slowly we're going to go through all the options that we need for our projects. We're going to learn what they do. At the moment, what are we interested in is the pin configuration. So to do that, we go to MHC, MPLAB Harmony Configurator. We go into Tools, Pin Configuration. Once we click that, we see 3 new tabs. On the first one, we can see the all the pins for the PIC, and the pins that can be used and pins that are blocked. Okay, now we've got the pin table describing what the pins are doing, and the pin settings, which goes now to the final detail of what the pins are supposed to be. So let's go to the pin table. Now I'm going to make this a little bit little bit bigger. There we go. In the module column we see what the pins can be set as. We've got the function in here and the name of particular pins. Now we are interested in our pins 4, 5 and 6, which are here according to our schematics. I'm going to bring it up again. 4, 5 and 6, there we go. Now let's scroll this down until we see GPIO in the module column. Function GPIO indicated by the blue square are the options that we can click and select that this pin actually is going to be designated as a GPIO. It's going to become yellow and then green, just to say okay, this has been taken, this has been assigned to a function. Now if we scroll up, you can see the other functions has been blocked out. You cannot click on it because it's been assigned to the GPIO. Let's go to the pin settings. Okay, now we've got GPIO 4, 5 and 6 in a custom name. We can change the name and we're going to do that right now. So PA04 is my red LED. Then I've got orange LED in a PA05 and a green LED on a PA06. Okay, so I'm going to rename them, and renaming that is very useful. We're going to see in a moment why. So this is my red LED, it's very useful to, if you don't know this yet, it's very useful once you name anything, any project or item in software, just to use the underscore instead of space, because some compilers or some software might not recognize it correctly as it is. So orange LED, and then I've got the green LED, green underscore LED. Okay, so now the function has been assigned as a GPIO. In here you can also select different functions. I'm going to keep it as a GPIO. It's a digital. We can change it to digital or analog. Once you click that, obviously the function is going to change. So I'm going to go back to the GPIO. I'm going to have to rename it quickly as a red LED. Okay, now direction. In here we've got in, out, in and out, or unknown state, high impedance. So we don't want to obviously leave it to the high impedance. Let's leave it to out, because we're going to be sourcing out some current. Let's do that for all of them. There we go, output. Now the latch. Latch means the initial state of the pin upon the programming. So we're going to say low, it's a 0, no voltage. High, it's 3.3 volts, which is 1. We're going to say low because we want LEDs to be off at the beginning. Now the current drive strength, I'm going to say strong in here. Okay, and this is it for the pin setup. Now let's click here to generate the code. I'm going to click generate, and once we've got the code generated, we could see like, oh well, nothing happens, but don't worry. What you have to do is go to the project tab in here. Now we've got our project files, then we're going to go to the source files, then double click on the main C to open the file and have a look what's happening inside. We've got our main function and our forever loop, while 1, and nothing else. So this is ready for us for our programming. In this video, like we said, we're gonna just set the state to high or low. So upon programming, the state that's gonna be permanent. LED is not gonna be blinking. The port is gonna stay as we direct it to be. How can we do that? Is by using some of the files that have been generated through our code from MPLAB Harmony. So we go to the header files, we go to the config, default, peripherals, because the peripherals are as our port, and then plibport.h, so peripheral library for the ports. And now in this very useful file, we can see that we've got the macros that we can use with the different pins on the port. Now in here you can see the names that we given in a pin configuration, which is very useful. As we said, it's better to see the name that you recognize straight away rather than some pin names given by default by the MPLAB. So in here we've got the macros, as well as if we scroll down, there are some other useful functions that we will familiarize ourselves later on in the videos. So there are functions and a description how to do it. If you read through them, you could probably decode what they do already. If not, just please stay with us and we're going to show you. Okay, so now at the moment we are interested in the two macros, red LEDs, basically LED set and clear for each color of the LED, which is the different pins. As we can see, red LED, PA04, orange on a PA05, and then we got green on a PA06, which is everything as we asked to be. Let's copy the red LED, actually set, yes. So what the set means is the set will activate the pin will turn it into the state 1, logic 1. Clear is changing it to the logic 0. So we've copied that set, go to our main, and in the while one, while loop, I'm gonna paste it here. Red LED set, we have to finish it by the semicolon. Okay, so when we program that, what we're expecting is our LED to turn on. Let me just make this a little bit smaller. We don't need that much space. I'm gonna try to move this out. Sometimes it gets stuck. There we go. Okay, I'm gonna leave it like that. That's okay. So on our board, what we can see is I have soldered the pins to the board to make it easier to use on the breadboard. I have sourced some ground from the board. I have sourced the ground, and then this is our connections from the pins PA4, 5 and 6 through the resistor to the LEDs. I have made, like we said before, the ground rail available. So each LED, let me just pull this one out, the LEDs like that, so the cathode goes into the negative rail. There we go. I'm gonna leave it like that. Let's go quickly to our user guide for the board. I'm going to make this a little bit smaller for a moment. Let's go to the pin out. There we go. So what is happening here? Again, we're using 4, 5 and 6 pin on the pin out, and also I've sourced the ground for the LEDs. This is or from the power supply, comes from the USB, so we're okay to use that. Gonna minimize that, and now let's plug in our USB cable to the board. Okay, there is that green LED starting up. We've got some files, open it up. Okay, let's close this kit window. Now this is our main file. Okay, I'm going to bring it up in here. So now we're asking the red LED to go to the set state to 1. So what we're expecting is, let me just grab that. What we're expecting is, this is the red LED connected to the 4, orange to 5, 6 is green. So we're asking for this red LED to turn on. Let's program the board and see what happens. Okay, I don't have my programming device button available because we need to select which device we're using. We go to the pin dashboard, big pin set dashboard. We click in the settings, properties. Now in here we should see our board. There we go. Now the compiler, and we're ready to go. Apply, and okay, right. So now I'm gonna click build the project and program it at the same time. Okay, build successful. I'm waiting to be programmed, and as we watch board, at the moment that the program has been sent successfully, the red LED comes on and it stays on. That's exactly what we've asked. Now let's add the other colors to the set. So I'm gonna copy that. Okay, and I'm gonna paste it twice, not 3 times. There we go. Okay, so we got red LED, not this, and we got orange LED, and we got green LED as well. Yes, yep. Okay, let's build this and program. So what we want now is all the LEDs to be set, which turn on, which means turn on. Let's wait for the program, build, and there we go, all LEDs on at the same time. Just gonna turn it sideways like that so you can see. Let's do the last exercise now. We know the function set. let's do the function clear. So we want to switch off the orange LED. Now I've typed something wrong in here. Well, we know that it's case sensitive, so okay, change the case. So we've got the red and green LED set, which we want them on, and we want to switch off the orange LED. So I'm going to build this and program at the same time. What we're expecting on the board to happen is the orange LED will be off, red and green on. Okay, so that's how you can manipulate those pins, how you can set the state on those pins. Obviously throughout the series we'll be using the LEDs as an indication of what's happening on the port. You can use a different device to be switched on or off, or however you want to send the signal to your depending on your project application. Thank you very much. Hope this was useful, and I will see you in the next videos. Thank you. Bye.